This is the wheel rotation expression. You can take a look here. That's the real wheel, which is this wheel. And it's the same thing that I posted on screen, with the exception of I'm using diameter instead of radius, because you can Google the formula for circumference, and it's C equals 2 pi r, which you know 2r is equal to diameter. So you could just say C equals d pi, and that's what I used here. And so basically all that's going on is for the pitch channel of the real wheel, for every 300 for the value of 360 degrees along the pitch value, rotate based on the z value of motorbike ground, which is what I'm using to move the vehicle back and forth, divided by the circumference. This is real world stuff. This is the stuff that we learned in junior high school. And therefore, if the wheels move by themselves, and it doesn't matter which direction. Furthermore, I added this throttle variable, and this is when I was talking about wheel spin, because the throttle variable, I'm using the pitch, as you can see here. I'm using the pitch, and it's equal to 1, which, as you can see here, pitch is equal to 1. If I made it 0, the wheel wouldn't spin at all, because as you know, any number times 0 is equal to 0. So, oops. As you can see, the wheel is not spinning. And then, of course, obviously, if I change it to 1, it's going to spin at the right speed. If I change it to a value of greater than 1, like 5, then you're going to get, the wheel spin, just like that. Okay, so what we have here is the map range function, and only thing it does is it reassigns values. Basically, it works just like a ratio. So if you go into the builder and you look at the directions, you can see this function remaps the data into input A, which is what I showed. Input A, that's your influencing channel. So I've got two bones here. This one's named top, and this one's named bottom. And top, let me turn off the expression. These bones are independent. So what I've done is I've taken top on its pitch channel, and I have its range mapped to the pitch channel of the bone bottom, and it's a 1-to-1 ratio. This is the low range of this top bone and the high range of the top bone. That's the first 0 and 1, and the second 0 and 1, or the third value and the fourth value, are the range of the bottom bone. And right now it's a 1-to-1 ratio, so they're going to move, as you can see, at the same rate. You can change, like, let's make the first one 2. And now this is a 2-to-1 ratio, and as you can see, bam, it's like moving much faster. Let's make it 2 to 4, and now the bottom one. And you can also do, like the bottom range as well. Like, let's make that one like 1.5, and that's 1.5. And as you can see, it's going a bit slower. You can make it negative, and it'll go into the opposite direction. You know, this is basically map range. Now, the sine function is basically my favorite because this is where I get all of my secondary motions from my animations. Now, I think I know where a lot of people get the sine function wrong. If you look into the expression builder, you can see that the example set is sine plus input A in parentheses. And if you read the directions, of course, this is the sine function from trigonometry. It is important to realize that the number that you will enter will be interpreted in the radian value, which is pretty much obvious because anyone who's taken trigonometry know that we work in radians. The problem that people have is when it comes to sine, which I have my my expression written here, they tend to forget the fact that sine is actually equal to 1. Basically, sine itself has a 1 in front of it because just like any x or y value, or just like any x or y variable, variables are equal to 1 until another value is assigned. And we can test that by, since I already have the expression running, along the heading channel of the bone, I'm running the sine function using this controller to assign value, and it's along the pitch. So what I'm going to do is I'm going to pitch it, and as you can see, it's moving left and right, and the maximum value that this is going to rotate, the bone is going to rotate, is 1. I'm at 0.97, but it's not going to be above 1 because sine is only assigned to 1. Furthermore, you have to look at the way I wrote the expression in the first video. I wrote y times sine times x in parentheses because the value inside of the parentheses to the right of sine only affects the domain. Basically, sine in trigonometry, for those who've never taken sine and cosine in trigonometry or haven't taken trigonometry at all, sine is basically a big circle. And if you look at the unit circle, you go around 1, 2, 3, and once you start thinking beyond 360 degrees, 720 degrees, etc., 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 you're thinking about linear motion. The reason why sine looks like a waveform when you turn it sideways, because you're talking about rotations over time. This is the reason why sine and cosine are used as waveforms, because it's cyclic. Therefore, what you have to do is you have to assign a value that's greater than 1 to the left of sine. But first, let's go ahead and prove how frequency, that this is frequency. So let's go back to this value, which we can see. We will set an initial value of 10, and we're going to move to 60 and set a value of 0. And the higher this value is, or basically the further this number is from 0, then the higher the frequency. And so as you can see, it's rotating. Let's do it that way. It's modulating slowly. If I increase this number, the initial value, you're going to get, let's go up to 50, you're going to get more frequency or a faster swing. Now we're going to increase the intensity, or we're going to increase the range. Now, oops, don't want to do that. I've taken the value. I've taken the value of the range, and I've assigned it to the heading channel of the controller here, but it's equal to 1. So, well, right now, since I've assigned it, it's equal to 0 because the controller is equal to 0. If I assigned it, if I gave it 1 degree, then that's the amount of, it's basically what we've seen before, because by default sine is assigned a value of 1. Now let's make this 45 degrees. And as you can see, intensity has increased. So the thing about the sine function, the cosine function, and many of the math functions inside of Lightwave, you have to assume that the function is assigned the value of 1, and something that you don't see on the left side of the function just may require a value just so that you can change things. And this is like perfect for gyrating and whatnot. I can slow it down again by adjusting the frequency. And if I adjust the frequency, I can shorten it also in the timeline by just moving it a little bit here, and it's going to go faster because change over time is happening faster. And I can leave the value the same. It'll go slower because change on the over time is happening slower. And so this is how the sine expression works. And one more thing you can do is, this is really cool, you can randomize mid-stride, which is something I like to do. And this is good for doing random things like struggle and whatnot. And there you have it. Then you can get rid of all of that. And right back to old reliable sine. And this is like a fading over time one. You could make it speed up and slow down, like, or slow down and speed up. We're at 25. We're going to make this one 50. And we're going to make this one like halfway. We're going to make that 0. And we're going to increase the intensity to 75 here. And let's make this 90. And let her rip. See? And this is the reason why the sine function, the cosine function, or what have you, those simple expressions like this are my favorite, because I get so much secondary control without the need to keyframe. And as you know, keyframing can get messy, especially when you're doing something like gyrating or you have a fading effect. No, you want to avoid keyframing as much as possible and use math as a shortcut. Anyway, that's the sine function.